All right, percents are another thing you won't be able to get away from. They can show up in so many different places, not the least of which is, of course, your data interpretation, data analysis. Three different types of percent questions you need to watch out for, and we'll talk more about each of these in more depth. Okay, so first off, percent of. 20% of 50 is 25% of what number? This is a different sort of calculation from a percent increase or decrease. So due to increased fuel prices, the price of plastic raised 12.5% between 2005 and 2006. If plastic cost $400 per half ton in 2005, then what was the cost of 1 ton of plastic in 2006? So with percent increase and decrease, we have something going up or down. Whereas this one is a straightforward arithmetic calculation. I guess this one is too in a way, but this one's more of a story problem where something's going up or down by a certain percent, which is different than just saying what percent of something is something else. This one's a straight out equation. This one you actually are doing some computation. And then finally percent change, which is different from either of these other two, and it has its own formula. A car goes on sale for $24,000. If the original price was $30,000, by what was the price of the car reduced? And it's by what percent? Okay, because it's percent change. We already know it was reduced by $6,000. So, yeah. All right, so let's talk about these in more depth. So first, your percent of. To find the percent of something, you multiply it times the equivalent fraction or percent. Which way to go is not always immediately clear because, quite frankly, sometimes it's even faster than typing it into the calculator if you have some common percents memorized. So for example, knowing that 50% is equal to 1/2 and 0.5, I mean, you would either be doing this in the calculator or this on paper, and sometimes this guy is going to be even faster. So to whatever extent you have extra space in your head that you can devote to memorizing these things, it's worth it. Since you do have the calculator, you never have to have them memorized, but again, since any time that you save on questions that are easier for you, that's time that you can devote to getting other harder questions right. So, and these aren't in order of importance, 2, 3, 4, 5, 6, 7, 8, 9, 10, they're in numerical order. But of them, the most useful ones, I would say, are those guys. So, knowing that an eighth is 12.5%, that's probably the weirdest and as far as you would need to go. Knowing that a ninth is 11.1%. I mean, again, if you know that stuff, that's great. I don't. I'm sorry. These are the ones that I know. I guess maybe that's why I decided those are the important ones. But since you have a calculator, you can do any other crazy fractions that you come up with. But knowing these and doing these quickly, it's a huge time saver on certain problem types. So totally worth doing. So when you get a question like 20% of 50 is 25% of what number, you could actually do it mathematically with the decimals. So 20% of 50, 0.2 times 50 is, that's your cue for equals, 25% of what number? Okay. So, and you end up with the same thing no matter which way you do this. You end up with x equals 40. You could also do 20%, so 1/5 of 50. So this is what I was talking about, how sometimes it may even be faster than typing it into the calculator. 1/5 of 50 is clearly 10, equals 1/4 of x. So 10 equals 1/4 of x. You multiply both sides times 10, or multiply both sides times 4, x equals 40. So again, it turns out the same either way. It's a matter of personal preference. This way is sometimes faster. So if you have a long enough preparation arc before your GRE, try doing some of these the quote-unquote hard way with the fractions. It may save your I was going to say save your life, but that's a little extreme. It may save your score. All right, so we still have those conversions on the screen here. So to find a percent increase or decrease, apply the percent and add the result to the original number, or alternatively add or subtract the percent to or from 1 to save an extra step. Maybe that's not clear what that's saying. I'll show you what it means. So due to increased fuel prices, the price of plastic raised 12.5% between 2005 and 2006. And if the price of plastic cost $400 per half ton, then what was the price of 1 ton of plastic in 2006? Okay, so clearly, first off, we have a price per half ton and then a price of 1 ton. We needed to get it consistent. So we start off with $800 per ton. And it needs to go up 12.5%. So $800. So what this is saying is either you apply the percent and add the result to the original number. So 800 times 12.5%, it'd be 0.125. Let's just do it 1/8, because that's easier, see, 0.125. 800 times 1/8 equals 100. So that's the amount it went up. We have to add that to the original number to see what the new number is. So the new price is $900 per ton. So that's what this first thing is. Apply the percent, that's this right here, then add the result to the original number for the new price. What it's saying, alternatively, add or subtract the percent to or from 1 to save an extra step. This would be multiplying it times 1 1/8. It's already got the 100% built in. 800 times 1 1/8 will equal 900. And so if we had done this with decimals, it would have been 800 times 0.125 equals 100 plus 800. And so we would have gotten all the way to the answer. Or we would have done 800 times 1.125 equals 900. So this is what it's talking about, saving a step. If you happen to see that if you're increasing it over its original value, you add that increase, this percent increase, to 100%. So it's actually the original price, the new price is 112.5% of the old price. It's a 12.5% increase, but it's 112.5% of the original price. So that's all that we're doing with this. If you're not comfortable with that, if you're worried that you're not going to see which way it needs to go, don't do it. It's not like it took us an extra 10 minutes to add in the original price. So however you want to do it is fine. And again, 1/8 in particular, the 800 times 1/8 jumps off the page as being much easier. But if you're not sure about that, there is always the calculator. All right, finally, percent change has its own formula. So when they actually use the phrase percent change, that's where you have to use this. It's the new number minus the original number or over the original number. Or, even easier, just think of it as the amount of change over the original. That is the percent change. So, if you get a problem like this, a car goes on sale for $24,000. If the original was $30,000, by what percent of the price? By what percent was the price of the car reduced? So the amount of change is minus 6,000, because it went down 6,000. You do need to put that minus in there, because otherwise you'll get the wrong answer. You'll end up with a positive when it didn't, when in fact it went the other way. So the amount of change over the original, which is 24,000. Oh, excuse me. That's not true. The original is 30,000. So, you know, you can reduce the fraction. So negative 6 over 30 equals negative 1/5, which is minus 20%. Using the chart or your calculator, whichever way is easier. So the percent change was a 20% reduction. So that's percent change, and this one you do need to have memorized. I don't think there's any way that you can rederive that formula or just sort of magic it up out of nothing by staring at the problem long enough, so do commit this one to memory.